this is Funda and you're watching on YouTube. So now we are going to understand the third question of weekly contest 449, and this was today Sunday, right? So Leetcode 35 45 and 35 46 and 35 47 we are going to do. Okay, so already we have done the last two questions, 45 and 46. Now this is 47. So let's understand the Leetcode 3547 number question, where I have already solved 3500, 45 and 46. So this is the third question of the today's contest, like weekly contest 449. Okay, so let's understand the maximum sum of A's values in a graph, right? So we should understand the problem, right, first. So pause this video and go through the statement. So let me read for you. So you are given an undirected graph of n nodes numbered from 0 to n minus 1. So for each node is connected to at most two other nodes, right? Means we have given undirected graph. Undirected graph means there is no directions given for the graph, right? And so there are n nodes in that graph that we can say 0 to n minus 1, right? And each node is connected to at most two other nodes. Okay, so there are n nodes, so we can say 0 to n minus 1 nodes are there, right? And for that, so the each node are connected with at most two other nodes. Okay, now it is saying the graph consists of m edges that represented by 2D array edges. Okay, and where edges at I is at AI and BI. That indicates that there is an edge between nodes AI and BI. Okay, so you have to assign a unique value from 1 to n to each node. So the value of an edge will be the product of the values assigned to the two nodes it connects. So your score is the sum of values of all the edges in the graph, and so we have to return the maximum score you can achieve, right? What we have to do, we have to assign a unique value from 1 to n to each node. How many nodes are given? We have given n nodes, we have given from 0 to n minus 1, and for each node it connects at most two other nodes, right? So the graph consists of some edges, right? But we have to assign unique value from 1 to n to each node, right? And the value of an edge will be the product of values assigned to the two nodes it connects. So if the two nodes are connected, we have to make the value product, right? So the score is the sum of the values of all the edges in the graph, but we have to return the maximum score you can achieve, right? So there is saying you can achieve maximum score, so that we have to do, right? So for example, we have given n is 7, so these are the edges are there, so 130 is the maximum score we can do, means the sum of the values of all the edges in the graph that it connects or not. So we have to create a graph, you have to understanding. So these things we will do, right? But first of all, we have to understand the problem, right? So better you pause this video, go through the statement, right? So what we have given, we are given a graph with the, let's suppose, 7 nodes in this example. Okay, and there are several edges we have given, right? Means 0 1 1 2 2 0 3 4 4 5 and 5 6. So these are the edges that connects the nodes, right? What? 7 nodes. So 7 nodes are from 0 to n minus 1, means 0 1 2 3 4 5 till 6, right? So each node can be assigned a value from 1 to 7. Okay, so the goal is to assign values in a way that maximizes the score, right? So the score is calculated by multiplying the value, right? Means the product, right? Means how we will calculate the score, means we will calculate the score, right, by multiplying the values assigned to the two nodes, right? That connect that these two nodes are connected by an edge, right? Right? And we have to do what? We have to sum these products that we are seeing. These products we have to do sum across all the edges. Like from 0 to 1 is one edge, 1 to 2 is one edge, right? So these edges we'll do the sum. First we'll do the product and then we will do the sum, right? So the score is calculated by multiplying the values that is assigned to the these two nodes that is connected by an edge. And then we have to do the summing these product across all these edges. I hope you understand, right? So what we have given in this example, we have given n is 7 and edges we have given like this, right? So the graph is connected, right? Graph has two connected components. How? So there is 0, 1. As you can see the edge, and if you make the cycle, the first cycle is 0, 1, 1, 2, and then 0 means is coming back to the 0, right? And other we have 3, 4, 5, 7. So this is a line. So this is a line and this is a what? Component, right? So this component is connected components and this is a line component, okay? Means, so next what we have to do, we have to assign the values 1 to 7. So let me show you the graph that we are saying about, right? So these two are like the first component is connected component, means 0, 1 to 0, right? And another is line 3, 4, 5, 6, like this we have here, right? Now think about the graph structure that the edge in these inputs are, right? So first we have given what, let's suppose we are going to assign the value, right? But before that, just think about these edges, right, that we have given. So first we have given what? 0 to 1, right? So the edge between 0 and 1 is called edge 1. So this will be called edge 1. Let's suppose we'll call 1 to 2, the edge between 1 to 2, right? It will call edge 2. Then we can 2 to 0 edge 3. Then 3 to 4 is 4, 4 to 5 is 5, and here 5 to 6 is 4 to 5 is 5, and then here 6, means 1, 2, 3, 4, 5, 6, right? So total how many edges are there? We have given 1 to 7, right? So all these edges we have are 6 edges we have, you can say, right? And so we have to make such a that we have to maximize the edge product sum, right? And for that we have to assign the values. So let's suppose we have assigned node 0, 5, 1, 6, 2, 7. How we have assigned this? So let's go back to here, right? So as you can see here, to assign the values to the node, right, we need to assign value from 1 to 7, right? And because we have 7 nodes, right? And we will try to assign the value in a way that maximize the score, which is the sum of the product of the value assigned to the connected component. See, you will say, yeah, why you are saying again the same thing, right? Because see, if you understand the problem, right, this example, you will understand everything, okay? So we have one cycle, one line, right? So after testing all the possible assignment, let's suppose the permutation of value 1 to 7, right? The optimal assignment is what? 0 will go to 5, right? 0 will go to the 5, 1 will go to 6, 2 will go to 7. Like this value will get assigned to these nodes, right? Why? Just think why. Because these are the best permutation, you can say, best, right? And so that we can say best assignment of value 1 to 7 for each node, okay? If you think that, then you will understand. Just assume for now, okay? So let's suppose let's calculate the edge value, right? Then you will understand. So there are cycle, right? So we will calculate the score. So for each edge we calculate the product of the assigned value for the two connected components, yeah, you can say nodes, and then we'll do the sum, right? So how many edges were there? Total 6 edges were there, right? So we'll talk about the cycle edges that we have given. So 0 to 1 is there, then 1 to 2 was there in the cycle, and third one was 2 0, right? And similarly we have the line 1, and you can do these things, you can do the sum, you can do the product of these, right, assignment value. And if you do the score, right, because this is permutation, I cannot show you every possible combination, permutation and combinations, right? You have to assume that I have assigned these values, okay? Then you will get the value 130, right? So total score you will you will get 130, right? And this is the maximum possible score for this graph, okay? So just think about that the previous value that we have given, right, this value, this is the best permutation of value from 1 to 7 that we have assigned to achieve the optimal assignment, or sorry, optimal maximizes the score, right? Optimal assignment that maximizes the score, that you can say, okay? And so we are calculating this value, right? Means the edges, if you pause this and you see the edges is 0 to 1 will give 30, is 1 to will give 42, and so on. We will get from the cycle, we'll get this, and from line we will get this, and we will do all the sum, we'll get 130, right? So why these values are important, right? So because see, the goal is to maximize the product for each edge, right? So by giving the higher value, let's suppose if you'll talk about, where was we here, okay? So we have given what? We have given 0 1 2 0 and 3 4 5 7, okay? So if we will write 7 6 5, okay, and we'll give this value what? 0 1 2. So 7 will assign to 0, 6 we will assign to 1, and 5 we will assign to 2, right? So we will increase the product of the cycle is where the node are tightly connected, right? Similarly for the line 3 4 5 6, we assign the value in such a way that the product of those edges are also larger, but not as large as cycle. You trying to understand or not? What I'm trying to say means we have to assign the value of line, in such a way that the product for these edges are also large, but not the large as the cycle, right? And so this assignment will provide you, will give you the exact value, right? That is 130, and you will get the answer, right? So if we will wrap up this example, right? So we can see what we assign the value, we assign the highest value, not the value, highest value to the nodes in the cycle to maximize their product. So more value will assign where? In the cycle one, right? To maximize their product, right? And the value assigned to the line nodes are also optimized to contribute to the overall score, right? But it should be little less, right? And so the maximum value we will achieve is score we will achieve is 130 for this input, okay? So what we will do, we'll go through some steps, right, to work on, right? So if you talk about what algorithm we are going to do, right? So the algorithm that we are going to use in this example is graph construction we'll do. Then we'll go for the BFS for the components, cycle and non-cycle separations. We'll assign some values to the nodes. Then we will do calculation of the product, and we'll finally return the result, right? Means for the graph construction, you know what you need to do, right? You will initialize an adjacency list for the graph. Then you will iterate through the S, and you will add each edge to the adjacency list, right? And then for the BFS traversal of the component, what you will do, right? You will create a visited array to track which nodes have been visited. So for each unvisited node, we will perform a BFS traversal to identify connected components, right? And then we'll track the size of each component, cycle or non-cycle, right? That we will do. So if this is let's suppose during the BFS, we will try to classify the component into a cycle one or non-cycle one. So we have to separate this, right? So a cycle is, what is a cycle means, you have seen, right, that 0 1 2 0 was there, right? So a cycle is a component where each node is connected to exactly two node at least, right? Like 0 was connected in starting or ending, right? And so and you see the line. So there was a cyclic and there was a line, right? So line we can say as a non-cycle in any other component. Okay. Next we will do assign values to the nodes, right? So assign value from n that we have given down to 1 for the node in each component, means we will try to maximize the s value sum. For cycle component, we will assign the value in an alternating fashion, right? For let's suppose 7 5 and sorry 7 6 and 5, right? Like that we have done, right? Like that we will assign a value in a alternate fashion. And for non-cycle component, we'll assign the value to maximize the edge product. Okay, then we have the to calculate the maximize score, right? So to calculate the maximizer score for each component, either this is cycle or non-cycle, we'll calculate the sum of the s, right? And the value of s is the product of the value that is assigned to the two nodes that it connects, right? And finally, we'll return the result. Okay. Then if we will write the pseudocode, so after this we'll write the pseudocode and I'll show you how to implement it. Okay, so in the step first, what we need to do, we will create adjacency list for the graph, then we'll initialize a visited array and the component list, then we'll do BFS for each unvisited node to find the component. We'll do sorting of the cycle and non-cycles by their size in descending order. Then we'll initialize the last value, that is the highest node value to assign. Then we will do assign value for cycle, then non-cycle, and then finally we'll return the total score. You know what we need to do after that, right? So let's do our hands dirty with our code and let's go to the Leetcode. See other examples also, right? So you pause this video and go through each examples to understand what we are trying to achieve here, right? So in the first example, we have 0 1 2 0, right? This is the example we have given, and then this is the line, right? So for this is an you can say cyclic, and this is non-cyclic. Similarly, we have a cyclic only, right? That you can go through. Okay, so let's understand the, you can say, pseudocode first, and then we'll understand the code. Okay, so let me zoom little bit. Okay, let me, and I'll summarize later. Okay, so as you can see, what we need to do, we have the given function here, right? That is called maximize score, and we will have you can say n number of nodes and the edges. Okay, so in the step first, we will initialize adjacency list for the graph, and for that, how we'll do, we'll create a adjacency list. You can take a list of you can say array list, linked list, right? And you can do that, and you have to traverse all the list, all the edges, and for all the edges you have to go by one edges, and then you will add all the nodes, you can say, for this node, this is the neighbor nodes. Like that we will add on the adjacency list. So we are trying to prepare the adjacency list here. Means first we will initialize the adjacency list, and we'll keep all the nodes and their adjacency, means their neighbors on the adjacency list, right? So that we will do in the step 1, right? Next we will do what, we will initialize a visited array and the component list. So how we are going to do, so first of all, we'll create a visited you can say array list, you can say, in the size of, or you can take an array, right? Number of nodes you can provide as a n, and then you can do what, cycle. In the cycle you can take a list of integers, and non-cycle is also a list of integers. So you will have the cycle and non-cycle here. Okay, then we'll create a loop, right? And we'll do BFS for each unvisited node to find component, and for that you have to go with node from 0 to n-1. If not visited, node is not visited, you perform the BFS to find their component, right, size, and for that we'll create a nested function, you can say, or iterative function, you can say, or other function that will do BFS, right? So BFS means first it will go the parents, then its both children it will traverse, right? So BFS will provide the urgency, node, visited list, cyclic or non-cyclic list will provide, right? So this is our current node, right? The node will start from 0 to n minus 1. Okay, so we'll go from each node 0 to n minus 1 node. Okay, then we'll do sorting. We'll do sorting of these two cyclic non-cyclic nodes in the descending order. So you can use collection dot sort, or you can do manually also. Okay, then we'll initialize the last values, the highest node value to assign, and for that we'll take a total score, and last will be n. Then we'll assign the values for the cycle. Okay, oh sorry, let me zoom out a little bit. So as you can see, from here to here we'll do what value assignment, in which we'll take the cycle value, right? So for each cycle we'll go with one by one cycle, and we'll assign the values to the cycle component, right? High and low value. So we'll start from 0 to cycle size, and we'll turn true, and we'll go like this, means we'll check if I is less than j. If turns, we'll add the what cycle values at last, and we'll do minus minus, and we'll do I plus, we'll keep increasing I. Otherwise we'll update into the cycle value from last, and we'll do the same thing, but here j minus will do, so that, and then we will do turn equal to not turn, right? Means switch we will do. Okay, further next step we'll calculate the score, how we are going to do the product, and then we'll do cycle size. We'll get the total score on the 0 to the cycle size minus 1, right? Similarly, we'll go for the value assignment of the non-cycle. We'll do the same thing, little changes. We'll take a mid by 2, and we'll check mid or mid minus 1. We'll make one loop for if cycle less than cycle, if the I is less than cycle or greater than cycle, right? And we'll assign the values. Okay, means we will assign the non-cycle values and the last. Finally, we'll calculate the non-cycle thing. We'll find the score, we'll update the score, and then we'll return the result after the score. So this is a little hard problem, so you have to keep your patience, right? Then the BFS, you can do BFS, you can mark as a visited each node you will provide, right? So all the current nodes we have to mark it as a true, and then you will keep adding those nodes into the queue while queue is not empty. You know how to do, you can poll these, then you can check cycle is cycle, you go through all the nodes like it's neighbor nodes, right? And then check the count is greater than, if is cycle, keep adding here, otherwise in the non-cycle. Like this you will keep continuing that. You will know the BFS rule, you will keep updating cycle and non-cycle in the BFS, right? As you can see here, and that is our pseudocode. Now understand the code, right? So in the BFS, right, you know the urgency list we will provide node, visited, cycle and non-cycle, right? So while it is not empty, traverse for all the its urgency neighbors, you go for all the neighbors, check if it is not visited, add on to the queue, move to the count plus plus, mark the neighbor as a visited, right? Ignore the single node component, check the flag. If flag is true, add in the cycle, otherwise add on the non-cycle. You can take a flag and you can check. Okay, now you have the cycle non-cycle thing, right? Then you build the urgency list, as you know how to do that. Then similarly you create a visited and cycle non-cycle. You call this method that we have already created, do the BFS from all the nodes, from current to all is neighbor nodes, you go all the nodes. Then collection dot sort you will do the sorting, right? And you have to override the method, default method, right? And you have to do b minus a, otherwise it will become a ascending order. To descending order you have to override it. Okay, then assign the value to the cycle component. How you will do that? Take a turn true, right? As you know, you can assign these values check the value. If it is in turn, put into here, do plus plus I plus plus similarly as I told you, otherwise make a switch. Okay, similarly your answer will get updated when multiplying the product. Then you can check in the cycle. If it is known in the cycle, right, you find the mid one by comp by divide 2, and you check if it is less than, you do plus plus value, otherwise you do the minus minus value here at I and j. Okay, just reverse it. Okay, and then you update the all the edges, right, and finally you will return the answer, right. So I will put this pseudocode and this code into the comment. Okay, and I hope you will enjoy this video. Thank you guys, thank you for watching this video. And if you'll talk about the complexity, right, so let's check the complexity. So first of all, we will go through the BFS, right, and we will traverse the BFS, right. So you know, the in the BFS, right, so we are also making the graph construction, right. So graph construction will take O of n time. Let's suppose m is the number of edges, so it will take O of m size, right. And for the BFS traversal, for this BFS traversal, it will take we are going for the nodes and edges also, right. So if n is the node, m is the edge, so we can say O of m plus n, right. And if we'll go for the sorting, right, we also going for the sorting this part. So by default it will take O of n log n for sorting the cycle and non-cycle, right. And to compute the, you can say, answer, right, the score, you can say, we are going for all the values, right. So it will take O of n times, as you can see, right, and finally we'll return the answer. So if you talk about the complexity, it will total will become what, O of n we are doing, then okay, O of n, then log n will take, we can take like this only, and plus m number of edges. Okay, so this will be your time complexity. Okay, if you'll talk about the space complexity, all right, so we are storing what, for a graph storage, O of m plus n will do, yeah, so it will take O of n plus n, right, yeah, because s and nodes. Okay, and for the cycle non-cycle also we'll talk about this one. Yeah, same thing we are doing right here also. Okay, so for this of n, so we are storing the size of the component also here. Okay, it will satisfy this one. So this will be your space complexities. Okay, so let me know if you have any doubt in this video, guys, and I will put this code and this pseudocode into the comment box. Thank you for watching this video. Please like this video if you enjoy this video and you understand. If you end out, please ping in the comment box.